Hi everyone, my name's Louisa and today I'm going to be showing you another example of how we can calculate the equivalent resistance in a complicated circuit with many different resistors. Alright, so here I've drawn a fairly complicated circuit with 1, 2, 3, 4, 5, 6, 7 different resistors, and each resistor has a resistance of 1 ohm. And what we want to do is find the value of the total resistance for this entire circuit so that we can redraw it as a simpler circuit with only one resistor of resistance R equivalent. So that's our goal for today. And what we're going to do is use the rules that we've learned about resistances in series and in parallel and try and simplify it step by step. So the first thing you want to do is look for the smallest, the most close together units of resistors. So what I mean by that is, like, if you look at this section up at the top, these two resistors are in series and there's nothing else that's interacting with them at that small level. In comparison, we have this other one which is in parallel, but it's in parallel with both of them. So what you want to think about is the green resistor that I've just circled being in parallel with one resistor that has the equivalent resistance for the two that are circled in yellow. You can't think about the green one being in parallel to one of the yellow or to the other one of the yellow because it's not really in parallel to them individually, it's in parallel to their equivalent resistor. Another example of two that are very close together is down here. We have two that are in parallel with one another, and it's just two resistors in parallel. There's nothing else at play when you're only looking at that small section. So that's another one that we can simplify. So I'm going to start with these two yellows. Since they're in series, we're just going to do R plus R, and that's, remember, R is 1, so we're going to replace those two with a single resistor of resistance 2. Now let's look at this one that I've circled in gray. And since those two are in parallel, we're going to do 1 over R plus 1 over R equals 1 over R equivalent. So we're going to say 1 over 1, this should be pretty easy, plus 1 over 1 equals 1 over R equivalent. And that means that 2, or 2 over 1, equals 1 over R equivalent. And R equivalent is 1 over 2. So I'm going to replace, oops, wrong thing. Sorry about that. I'm going to replace this bottom loop with a single resistor of resistance 1/2. So basically what we're doing is we're just applying the rules that we've learned about resistors in series and in parallel at small increments and then sort of building our way up to simplifying the entire circuit. So now there's a couple more things we can do. We can look at this loop, which is just now two resistors in parallel, and this loop, which is just two resistors in series. So let's do this one first because it's easier. We just have R, which is 1, plus 1/2. So we have 3 halves. And I'm just going to replace this with one resistor of resistance 3 halves. Let me do it in red since I've been doing the other ones in red. And then up top we've got 2 and 1. So let me just change what we've had over here. We have 1 over 1 plus 1 over, oops. Yep, it's 1 over 2, because R2 is 2 in this case from here. And we get 1 over R equivalent. 1 plus 1/2 is 3 over 2, so R equivalent is 2 over 3. Now we can replace this loop with a single resistor of resistance 2/3. And so now we've got two possible loops. Electricity can travel this way, or it can travel this way. So the key here is to think of those as those two different paths that electricity can take can be thought of as two resistors in parallel. it'll behave the same way. So let's start with the blue because it's easy. It's just 3/2 plus 2/3 because they're in series with one another. And we end up with 13 over 6. So we're going to redraw this circuit, by the way. It's a lot easier if you do it that way. So we're going to say that this resistor is 13 over 6. And this represents the blue path that I've traced out. And now if we take the yellow path, it's going to be the same thing plus 1 because it's got this 1 R, which is 1 ohm. And so that means it's going to be 19 over 6. So this one's 19 over 6. And so now our last step is just to simplify this very small circuit. So I'm going to need some more space. But we're going to do 6 over 19 because it's 1 over R1 plus 6 over 13 equals 1 over R equivalent. It's a little bit trickier because 13 and 19 don't really work that well. So multiply. Oops. Those are both supposed to be 19. It's a little hard to read. So I've just gone ahead and simplified these, and it's going to come out to 78 over 247 plus 144 over 247, which equals 222 over 247. And that's our total resistance for this circuit. So again, our total circuit can be simplified to a single resistor of resistance 222 over 247.